Hello guys and welcome back, and I hope you are all doing well. So today here we received an ASUS laptop for repair. It doesn't turn on, so it's a no power case. So let's see whether we can fix this today for the customer. Okay, so let me open the laptop. Okay, so this is a Pentium laptop. Okay, so look at the ampere reading. I'm going to connect the adapter. So the ampere reading is fluctuating. Actually, you can see going to 1 milliamp, then back to 0. So it's fluctuating. Okay, I press the power button, no responses. All right. Okay, so let me disassemble the laptop and take out the motherboard so we can start our diagnosis from the basic step. So from the main power rail, then to the inductors, and then we can go to everywhere on the motherboard here. Okay. Small ants are going here and there. Okay. Always ants are serious killers for all electronics. So on earlier computers they have bugs, real bugs, and nowadays we have electronic bugs. So on those days they used to remove bugs by removing the computer. There will be real bugs, but in today's context we have electronic bugs. That's the thing, only difference. So before that we will remove the battery. Always detach the battery before removing the display cable, so it is safety for you to not to short either CPU or EC chip. Okay, I'll just try to lift it. Okay, all right, so the board is out. So we have a small processor here, Pentium processor. We have onboard RAM module, EC chip is there, which is KB902AQ. Okay, I have never seen this kind of EC chip. So I have seen KB9012, but this is KB902. Okay, that's interesting. No problem. Okay, let me keep this aside. We can check only the motherboard. All right. Okay. Right. So let me connect once again the adapter and see if there's any change. So look at the ampere reading. Yeah, still same. It is fluctuating, right? Going to 1 milliamps, then 0, 1 milliamp, 0. Okay. First, we need to check the main power rail. Let me see whether we have a main power rail when we plug in the adapter, right? So the main power rail is on the other side. Any capacitors? Yes, we can find it from this place here. Okay. Checking the voltage. No, we don't have voltage. Okay. What about the impedance? Oh, we have a short, right? we have a short on the main power rail. So most probably the capacitor has gone shorted. So it's really an easy fix, I think. I don't know. Let's see. So before injecting the power, we need to check whether all the inductors are safe. We need to get high impedance greater than this one or less than this one. Which one? So whenever you check the impedance or whenever you have a short on the main power rail, you should not have the same reading. Okay, if you look at this one, we have 0.006. So you should not find this kind of same reading on any inductors. So it can be lesser than this reading or greater than this reading. Okay, we have 500, fine. 500, okay. 43, fine. 51 is okay. Oh, we have 4 here. So somewhat similar to this one, right? But less than this one. 4, let me check it again. 5. Yeah, that is same actually. So this coil and the main power rail having the same impedance, which is very low, and that is unusual. So what is this one? Most probably this is the battery coil. Okay, let me check the continuity. Yes, so this is the battery coil. Okay, so we have a short on the battery coil, right? So we should have high impedance on this one here with regard to ground. So what would be the possibility? Either this upper MOSFET is shorted. Okay, so I think the capacitor on the main power rail got shorted, and also the upper MOSFET of the charging section also got shorted. That's why it is reading low impedance at this point, that is equal to the main power rail. The impedance value is equal to the main power rail. Okay, so if the upper MOSFET got shorted, so it acts as a jumper wire from the main power rail then to the battery inductor here. So how can we find that? Okay, here we have the current sense resistor of the battery, and yeah, it is also shorted. Okay, yes. So up to now we have high impedance on all the coils except the battery coil. So injecting the voltage will not kill anything like CPU or EC chip or anything on this motherboard here except this battery section. So okay, right, so let us inject the voltage. So I will set to like 1 volt. Okay, so this is my presetting, 1.8 volt, maximum of 4 amps. So that is fine. So let me connect the adapter here, okay, to provide the ground potential, and I'm going to use this probe here. So this probe is connected straightly to the positive terminal of the DC power supply. So at this point you will get the positive voltage, and here we have the ground potential. So now I can touch it anywhere to inject the voltage into the motherboard. So it will be easy for us to inject voltage anywhere. Okay, where is my handy tool, which is this one here. So I can check the temperature reading when I inject the power. So 2 amps is consumed by the motherboard, and we don't have anything at this point. Now 3 amps. Okay, it's reading 35 at this point. I think this capacitor gone shorted. mostly this one here. Okay, checking the main power rail. No, still it is shorted. Okay, right. Now I can't read the temperature reading here because now it is really hot. So let me leave it for a while to cool down the board so that we can check other things here. Yes. So no any burn marks or cracks on the capacitor. Everything looks fine. So this time we can just increase the voltage. Up to 2.5 volt. That's enough. Okay. Okay, 4 amps. Okay, so something is happening on this side. It's going to 40 degrees. Let me see it on the other side. What's there? Okay, something was getting hot on this side. So as I turn around this point, here we have this IC here. And if you look at this capacitor got cracked. So you can see a crack there. So most probably this has gone shorted, and this should be connected to the main power rail. So let me check it. Okay, yes, it's shorted. Okay, let me remove that and see whether the short has gone. Also we have another work to solve the battery line short. Okay, remove this capacitor. Let me check again from the main power rail. Yes, so we have no longer shorted on the main power rail, so that is fine. Okay, what about the upper MOSFET at the battery coil? It is still shorted. Okay, so the battery coil is still shorted. So if you look on this side here, we have two capacitors for filtering the battery voltages, which is this one. So if this capacitor has gone shorted, then this inductor will show us the reading as a short. So I think yeah, we can remove this one from the current resistor, then we can find whether there's a short. Okay, yes, so we'll try to remove or isolate this current sense resistor from this place and check whether we have a short on the inductor here. If we have the short on that point after removing or isolating the current source resistor, then the problem is with the lower MOSFET here. So that is connected straightly to the ground. If the lower MOSFET got shorted, then it will connect the ground point to the inductor here. Okay, right, so let's see. Now let me check on the other side on the inductor. Yes, yeah, now we don't have short, so the short is only on this side. So as I was guessing, these two capacitors or this one is the faulty. So I think we can remove all of these. Okay, we can replace another 3 of this one. Ooh. So we have a plastic here, it is going to melt. So let us use the aluminum tape. So we can use a small bit of the aluminum tape so it can protect from melting it from the heat. Okay. All right, so let me check the impedance value straightly on these capacitors here. Yes, now we don't have short. Okay, right. So we need to replace 3 of these capacitors. Then we are good to go with injecting the power. I mean connecting the adapter and check whether the board is turning on. Okay, right. Okay, so we have replaced all the capacitors. Everything looks fine. So before injecting the power, let's reconfirm whether main power rail is not shorted. Yes, so that's fine. Okay, battery side. Yeah, everything is fine. So let me change to 19 volt. Yes. Injecting the power. Yes, we have the adapter light. I got the light here. Yeah, we got the light. But it is recycling, right? It is turning on and off again. Why is that? Okay. It's turning on and off. One volt. So it is fluctuating on and off. Zero 0.9 volt. Yes. What do we have here? We don't have anything. Yeah, 1.4 volt. Why is that? So we don't have removable RAM slots, so only we have the onboard RAM. So this is RAM voltage and we have 1.4 or something. Okay, here 5 volt, 3.4 volt. Okay, let me disconnect and connect again. Yes, it is shutting down again and again. Okay, so what about this one? Okay, the main power rail is actually turning on and off. So that's why it is going to 0 completely on the ampere reading. Look at the DC power supply. It is going completely to 0, then back to the ampere reading. So, and here also you can see on the multimeter, it is showing 19 volt, then back to 3 volt, and it is fluctuating. So what's the problem then? So the charger IC is actually cutting the voltage into the motherboard. So if the charger IC senses that a high current is being drawn by the components in the motherboard, then it will cut the voltage into the motherboard here. There can be this instance. So we need to check that why it is switching on and off the main power rail, because we don't have any short. So okay, let me check the inductors. Yes, 44 okay, 37 okay. So everything looks fine. Okay, so let me connect the adapter once again. Yes. So now I am going to short the second MOSFET here from this place and see whether we are getting the main power rail constantly and whether board is staying still. Okay, just to confirm whether the problem is only with the charger IC here. So here we have the second MOSFET. So on this point we have this first MOSFET. So we need to check that. So this is source and this is drain. So N-channel MOSFET is always from source to drain. So shorting the second MOSFET will not help us here because the diode is in a reverse blocking for the adapter voltage. So we need to short this one from here to here, so then we will get the voltage into the motherboard. Okay, so now the voltage is stable, right? I didn't notice that. Okay, so let me check it again. Yeah, I think the display may be executed. Let me connect the mouse and see. Yeah, we got the display. We have some loose connection with the mouse here. Okay, so let me disconnect and connect again. Yeah, again it is shutting down. Okay, let me check the diode value of the first and second MOSFET. From source to drain, 496, okay. From source to drain here, 522, so that is fine, everything is okay. Checking the gate and the source, good. This point here, yes, good. So let me just try to resolder these two MOSFETs. Yeah, it looks fine. Let me test again. Next time I will just reflow this charger IC here, because dry soldering also will make this type of problem. So in the previous video we saw that only because of the dry soldering, after some time the board shut down completely. So this is also a similar phenomenon to that. No, still it is turning on and off. Okay, let me reflow the charger AC once again here. But it looks fine, I think. Yeah, it looks fine. Anyhow, out of my trust, I'll just try to resolder this one. Okay. Okay, let me connect it again this time. No, still it is shutting down. Restarting again. Yeah. So let me try to short these two pins, the source and drain of the first MOSFET, and connect the adapter and see whether it is staying still. Okay. Yes, so now no, it is shutting down. Okay. Wait a minute. Okay, now it is stable, right? So now it is stable, and I think we got the display. If I take it, yeah, it is shutting down. Then again it is restarting again and again. Okay, so the main power rail is actually turning on and off by the charger IC here. So that is the problem. So we need to find that, why it is behaving like that. Input voltage for the charger IC 19. Okay, let me check the ohms value for the input resistor of the charger IC. It should be 10 ohms. Oh right, 185 ohms. So this is the problem, I think. Okay, so this should be 10 ohms. So that's why the charger IC is not getting enough current to produce the charge pump voltage for the MOSFETs here. So these two are internal MOSFET. They need to have 25 volt as a voltage at the gate point. And here we have 188 ohms. So as this resistance increased, the current for the charger IC will be reduced. So it will lose the capability to produce the charge pump voltage of 25 volt. So I'm just guessing. So let me just replace this one, this 10 ohm resistor here, and check whether this charger IC is working fine. Okay. Okay, so let me check once again the resistance value of this resistor here. Yes, 10 ohms, so that is appropriate. This time I think we should get a stable main power rail output. Connecting the adapter. Wait a minute, I'll just turn on the camera of the DC power supply. Okay, right, yes, turning on and stable. Okay, it is shutting down, it is restarting again. So that is just a power cycling. So if you look earlier, the voltage, the current reading went to zero, completely zero, then again it is coming to 200 milliamps. So this time when I connect the adapter, it is not going to zero, it is going to standby, so that is okay. So there is some ampere reading. Did you see that? 20 milliamps, 24 milliamps, then back to 200 milliamps. So that is fine. But before we had, it went to 0 milliamps to then back to 200 milliamps. So that is actually main power relay switching on and off. So that is the scenario there. But this time it is okay and working fine. So this resistor was faulty. Which one is here? 10 ohm resistor. It was 188 ohms. The power for the charger IC was not enough to provide the gate voltage for the first and second MOSFET. So I just shorted for checking purpose the first and second MOSFET whether the main power relay is okay and if it is working fine. So but do not always short the first MOSFET by using a jumper wire, because the charger IC is there to protect your components in your motherboard here. So it is like a gatekeeper. So if any theft comes inside, it will block it. So if there's any short on your motherboard here, then the charger IC will not provide the gate voltage for the first and second MOSFET, and the main power rail will be absent. You may have noticed when I first connected the adapter, before removing the short on the main power rail and also on the battery section here, the charger IC was not providing the gate voltage, and we didn't find a main power rail on this capacitor here, because the charger IC has detected that there's a short on the main power rail. But if you remove this MOSFET and just short from its pin together, what will happen? There will be continuous 19 volt into the motherboard. Even if any component got shorted, there is no one to protect your component here. Unless your adapter cut off the voltage only, your motherboard will be safe. So charger IC is more faster than the adapter. It will detect the voltage, it will detect the short on your motherboard, and it will cut off the voltage into the motherboard here. So if the main power rail is shorted through the capacitor, any capacitor on the main power rail, that is not a problem. But if anything on the main power rail, such as if the upper MOSFET of the CPU line got shorted, then it will be a jumper from 19 volt to the inductors of the CPU coil here. So if this MOSFET got shorted, or if you remove this MOSFET and just put a jumper wire here, always you will get a 19 volt into the inductor of the MOSFET, inductor of the CPU. Then at once it gets the 19 volt, CPU will be damaged. So the charger IC will respond immediately if the upper MOSFET of any of the CPU section or any section got shorted. It will immediately cut off the voltage into the main power rail. Then your components, everything will be safe. So I have seen many of the laptops which I received for repair that has this MOSFET taken from the motherboard and has been shorted with a jumper wire from its source to drain. So there's no control for this MOSFET. So if there's no control, the voltage will be always present if you connect the adapter. So the charger IC responsibility will be cut off, and there is no person to protect your motherboard here. So it's very important for the charger IC, and also it is very important to protect your components in this motherboard here. So do not always remove these two MOSFETs. So if the charger IC is not driving these two MOSFETs, find the problem why it is not driving this these MOSFETs. So instead you should not remove this MOSFET and put a jumper wire, and it is really dangerous for your motherboard here. So at any time your components can get shorted. So in this kind of motherboard, this is just a small, a low-end CPU here. But in high-end laptops, so you will find an expensive CPU on that place. So on that case, you must be very careful with the first and second MOSFET, and you need to provide the control of the first and second MOSFET to the charger IC. Then only it will detect the short and it will cut off the voltage into the main power rail here. Okay. And also I wanted to say another feature of the charger IC. So whenever you connect the adapter, the charger IC will not immediately turn on the main power rail once you connect the adapter. So it will make some delay, like around 50 milliseconds or 150 milliseconds. After some delay only, it will switch on the main power rail. So which is called as a soft start function. So soft start means once you connect the adapter, it will take some delay, and then only your adapter voltage will be transferred into the motherboard. But if you short these together, so once you connect the adapter, you will get some spark on this DC connector here. So, and that is not actually good. So if there's a spark on the DC connector, it will impact on all the main power rails. The voltage can ripple, which means it can go high and low, and it can damage the capacitors also on this place here. So the charger IC is having a soft start function. So once you connect the adapter, it will take some delay, and then only it will turn on the main power rail here. So these are the benefits of the charger IC and also the first and second MOSFET. So importance of first and second MOSFETs is really vast. Okay, right. So let me assemble this inside the laptop and go for a last check. Yes, you can see 400 milliamps. So there's a problem with the display, so we will not get any picture, just we will get the backlight, then we can know that the display is executed. Yes, so we got the display now and everything is working fine. So thanks for watching guys, and stay tuned for our future updates. And I just thought to do something interesting from my video, this one and future videos. So after the end of the video, I will just share you one question, so you can freely answer those questions here. So it will be more interactive from the videos, repair videos that we learn here. So the question of this video today, what do you mean by soft start function of the charger IC here? So any charger IC, it has the soft start function. So what do you mean by that? So I'll just pin this question on the comment section, so you can freely answer to that question, so it can be more interactive with me and you guys. Okay, so thank you guys. So stay tuned for our future updates, and bye for now. Okay.